Now that we have created NP arrays in whatever dimension that is needed, our next step would be to perform operations on that data. NumPy provides different types of functions to perform these operations. Hello viewers, in this video I'll be explaining you on some of the operations that can be performed on ND arrays. Click on the like button if you like this video, subscribe to my channel to get alerts on more videos on data science. Typically, a very basic operation that we would want to do on data is the arithmetic operation. NumPy supports these operations by using the operators and also by using functions. Let us consider two arrays of the same shape. On these arrays, I can do addition, subtraction, multiplication and division. I have this array ARR1, which is a 3D array which is going to be of 4 rows and 3 columns. Similarly, I have ARR2 which is of the same shape. And this is how I can perform the operations. So in this example, this is my first 3D array and this is my second 3D array. And the result is going to be the addition of these two 2D arrays. So which is 25 plus 1 is going to be the first value in my resultant 3D array. So similarly, 26 plus 2, which is 28, is going to be the second value in my 3D array. And this is how the arithmetic operations can be performed on the ND arrays. What if the shape of the arrays are not the same? So it's so obvious that NumPy is going to throw me an error. If the shape of one of the arrays could be broadcasted to the shape of the other, operations can be performed on these two arrays. So consider this example where my first array is going to be a 3D array and my second array is going to be a 2D array. So when I try to perform the arithmetic operations on these two arrays, ARR2 is going to be broadcasted and operations will be performed on that. This example was all about adding values using two arrays. What if I want to find the sum of values across all the rows or columns in the same array? In that case, I can call the sum function. This is an example of 1D array where this sum function is going to add the values of all the elements. I can simply give sum of the array name to find the sum of its values. Here I can see that 45 is the sum of all the values of this 1D array. In case of 2D arrays, the sum will add all the elements along its axis. So if I give sum of ARR1, it's going to add the values in each and every column along the vertical direction. 0 plus 5 is 5, 1 plus 6 is 7, 2 plus 7 is 9, and that is how the sum function works on 2D arrays. Do I have an option to choose along which axis the value should be summed up? I'll have to call the sum function a little differently. Rather than giving sum of ARR1, I'll give ARR1 dot sum of axis is equal to 0. This produces the sum of values across the vertical axis. If I give axis equal to 1, it is going to produce the sum of values across the horizontal axis. If I want the sum of all the values in the 2D array, I'll just have to give axis equal to none. So this is going to give me the sum of all the values in the 2D array. The same applies for the ND arrays as well. This is the same as not specifying the axis. We can just give array name dot sum and it is going to give me the sum of all the values present in the array. So in case of 3D arrays, the sum will be the addition of elements in the two 2D arrays, which is 25 plus 37 is going to be my first value, 26 plus 38 is going to be my second value, and that is how the sum function will generate the data if we give the axis to be 0. If I give axis to be 1, then it will be the sum of values in the vertical axis of each 2D array, meaning 25 plus 28 plus 31 plus 34, which is 118, is going to be my first value in the resultant array. So similarly, the sum of these 4 values is going to be my second value, and sum of these 4 values are going to be my third value, and all these are going to be in the first row of my resultant array. And this is how the sum function works when we give axis equal to 1. We can also perform the exponentiation operation by giving double asterisk, by giving ARR1 double asterisk 2. So each and every element in the array 1 will be raised to the power of 2 and the values will be displayed in the result. So 0 power 2 is 0, 1 power 2 is 1, 2 power 2 is 4, 3 power 2 is 9, 4 power 2 is 16. So that is how the result will be produced if we give ARR1 double asterisk 2. I have shown you an example of element-wise product using the asterisk symbol, which is nothing but the multiplication of two arrays. We can also perform a matrix product on the array data. So this is also called the dot function. Let me show you with an example on how we can do the matrix product. I have two arrays here which are ARR1 and ARR2, and both the arrays are 2D arrays. The matrix product can be performed by using the @ symbol. So let me explain you how it works. The ground rule is that the number of columns in the first matrix should match the number of rows in the second matrix. This is my first matrix and this is my second matrix. The number of columns, which is 2, is matching the number of rows 2 in the second matrix. This is the result of the matrix product. And how did we get this product? The way it works is 25 into 2 plus 26 into 4 will give me 154. Similarly, 25 into 3 plus 26 into 5 is going to give me 205. 27 into 2 plus 28 into 4 is going to give me 166. Similarly, 27 into 3 plus 28 into 5 is going to give me 221. The other way to perform this matrix product is by using the dot function. I can simply give ARR1 dot of ARR2 and it is going to give me the matrix product as the result. These operations on ND arrays create a new array of the resultant value. What if I want to perform some operation and update the existing values in the array? In that case, I can make use of plus equal to asterisk equal to update the values in the existing array. In this case, I'll be using two arrays to perform this operation. In this example, I have ARR1, which is a 2D array, and ARR2 is also a 2D array. And I'm going to update ARR2 based on the values from ARR1. So I can use plus equal to, which means that ARR2 equal to ARR1 plus ARR2. So I'm updating the values of ARR2 by adding the values of ARR1 and ARR2. When I print ARR2, this is going to be the result. The first value of ARR2 was 2. So now I am updating it in such a way that it is going to be 25 plus 2, which is 27. So similarly, the second value is going to be 26 plus 3, which will be 29. And this is how the plus equal to works. Similarly, we can give asterisk equal to, which is going to perform a product on these two arrays and have it updated in the ARR2. To get the minimum and maximum values from an array, we can call the min or the max function. So I have one 2D array which is ARR1 and I'm calling the min and the max function on that 2D array, which is going to return me the minimum and the maximum value from that array. NumPy provides certain mathematical functions such as sine, cos, exponent that operates on each and every element of the array. These are called the universal functions. So here I have ARR1, which is a 2D array, and on ARR1 I'm printing the sine, cos and the exponentiation value. These universal functions get applied on each and every element in that array and it is going to return me the result. I believe you have got a clear picture on various operations that can be performed on ND arrays.